Alright, so as guitar lovers, we all like to play guitar, but sometimes we feel that we're not loud enough and we're not causing enough havoc. So we're taking an acoustic guitar, very much like this one here. That's quite quiet and could probably please a room, and we're going to change into an electric guitar, which could please the whole crowd. And yeah, and we're going to be applying Faraday lens law, and hopefully it'll work well.
Okay, here we go.
So intense.
This is starting. Oh, I just can't wait to get it up.
I'm really excited.
This is important. We need this.
It's
This
a
is
mini
the
amplifier.
Closer.
It's important that it's small so that the sound, we don't need too much of a sound. We just want to see that it works.
Yeah, amplifier.
This is the good stuff.
This is the very high quality fine wire that we'll use to wrap around probably the permanent magnets to create our coil. So this wire will lead to our audio jack, and we'll pick up the changing flux and current from the string.
This here is the audio jack that we'll connect our copper wires to. This allows us to take the sound from our copper wire and go through this 1/4 inch cable into the amplifier.
This is
Okay, this can be used for a lot of things.
This is a block of wood with a metal plate on top.
So we could use this. Oh, do you guys see what that?
Oh, this is for winding. You put this little bit over. See this little bit over here? That fits into the Do we have a drill?
We drills this.
Okay, open that box and see.
Oh,
We should open this.
Why don't we open the box and show the
a
drill?
CD case.
This is to record our hit single.
Of course, there's no CD in it, but that's fine. We don't need it.
We're just that talented. Okay.
Oh, baby.
Oh.
Oh, the good stuff. That is hot. Okay.
Okay, so assuming that this
Guys.
bit fits in that drill, this will
Oh,
spin.
this is for winding.
No, they're both for winding. This is for the fine tune.
This and this are two pieces of the same thing, I think. Like this doesn't actually wind anything.
No. This is for the high speed winding later on. Why is there a metal one?
What the hell is this?
Magnets! They're magnets. They will
You think you can magnetize this? We could, but like, why? Why is there a metal plate on
It's
this?
kind of magnetic. It should be. No, it's not.
Oh, these are wire cutters.
Wire cutters. As you can see, they cut different thicknesses of wire.
So these are ferromagnetic strings. We need them to be ferromagnetic so that way the permanent magnets will magnetize them, and when the strings move, they'll have changes in flux to create current.
We're probably going to get really hungry doing this, and here are some chopsticks that Mrs. Lawrence gave to us. Clearly, only one pair because only one of us needs to eat. And also, two pairs.
And some
two of us
other-
will eat and one of us will not. But we can use these chopsticks to make kind of a saddle right across the center of the guitar, which we will then put our
Where's the solder?
what do we call this?
Wire.
Our pickup on. So we're gonna put on the pickup.
This here is our soldering iron
And that's the solder.
This is our solder, and this is our soldering iron used for
Connecting different
connecting wires
solder
together
irons.
and
Yeah, so we have a few types of wire. As we already talked about, this wire here is thinner than a hair, and we have 4 kilometers of it. It's actually quite a lot. It doesn't look like it, but if you can imagine a whole pound of hair, probably be a whole kilometer long as well. Yeah, so that's really cool. But if we mess up with this guy, we're gonna have to use this guy, Gabe.
with this guy.
These are slightly thicker, shows the camera.
So if you can see the difference in thickness, probably not, but you see you have these two guys, and this guy seems to be probably even a millimeter thick already, or half a millimeter. You can already feel the actual pointiness of the wire. Yeah, so you can feel this is the thickest one, this is the least, this medium thickness, and this is the least thick wire. And hopefully we can use this for the whole thing, because then we can get more loops, and that will definitely create a stronger current, because we know that the more rounds around...
Aviv,
That's tape.
it's not sticky. It's just rubber.
Yeah,
Ooh, we could totally use that.
for wires.
Or covering the wire.
Yeah. You know how...
These pliers here can be very useful for restringing. It's hard to grip the copper copper wire or the
Also
strings.
bending wires.
Yeah.
This could be very useful for bending wires.
Or if we don't have any.
Or for soldering.
Soldering while holding the wires, yeah.
We decided to use wood for the body of our pickup because it was easier to cut than the plastic and we could drill holes in it easier. We decided that we would use 8 centimeters for the body of our pickup because that's exactly what will fit in the sound hole. So this is essentially the design of our pickup. What's happening here is we have the magnet in between here and it's going to be secured. It's going to be secured. It's going to be secured to either one of these planks of wood. And then we're going to place this into the sound hole, just like that. The bottom part of our pickup will be suspended in the guitar sound hole, and the top part will be secured, and we're going to push it all against here, and use tape to tape it to the guitar.
Here, Aviv is drilling holes in the pickup for the magnet to go into. As you can see, we've marked off the holes with even spacing, so that way it lines up with the strings. Yeah, we can. Did one of them come out?
And I'm on the track, that's good.
Yeah.
Feel that. That's so cool. This is the finished product minus the coiling of our pickup. Right now we're ready to coil it, and that's what it looks like. We glued the bottom piece onto the magnets, and it's ready to be coiled.
Guys, this is awesome.
Yeah? So? For sure.
Okay, this is a finished product of our pickup. It's been completely coiled about 2,000 times. Took us about an hour to do, averaging 30 turns per minute. And so here it's been wrapped 2,000 times, and at the ends we stuck nails in and wrapped this coil around the nail, and then we're going to go, the current is going to go through this nail, and because the nail is a conductor, we can go from this nail now to the audio jack, which connects to the amplifier.
Okay, so the next step here is to strip the rubber insulating off of the inner part of the wire so that the inner part of the wire can touch the conducting nail. So I'm going to go ahead and do that.
Wait, hold on.
The best way to do this is actually with your nails if you have them.
So what's going on? So why are we soldering in the first place?
Or what is solder?
Okay, so in the beginning, what we didn't realize was that the copper coil, although it only being the thickness of a hair, is still insulated.
That's this coil over here that's wrapped around the magnets.
And if it's insulated, we can't use it. We can't connect to the iron nail or the steel nail.
This coil must be insulated because when it's coiled around, if it's not insulated, it'll just act as a ring, not as a solenoid. Because instead of individual coils around, it'll be one big coil and it won't get that adding effect.
So what we
it
need
must
to
be
do
insulated.
was sand down right off the insulation and solder it directly onto the nail. And then we solder the wires onto the jack, and then the jack goes right onto the
soldering.
amplifier.
The solder itself helps with the electrical connection.
Here we see Gabe and Aviv soldering insulated wires from the nails to the audio jack. So, Gaby, can you explain to us how the guitar pickup that we created uses the Faraday-Lenz's law of magnetic induction to pick up the sound?
Okay, well, the first way that happens is that the basic idea of the pickup is that you have a flat base underneath the string, the string is going this way, and in that base are permanent magnets. Now, these permanent magnets are quite strong. They actually magnetize the strings above, which means that they interact magnetically with the strings. So when the strings move, the magnetic field around the magnets changes. So another way to talk about that magnetic field, which is important in Faraday's law, is magnetic flux, which is essentially talking about magnetic field over an area. So what the Faraday-Lenz law states is that when you have a changing flux or a changing magnetic field in an area, a conductor in that field will experience current that will create another magnetic field to oppose that initial change. That's a little complicated, but essentially what it works out to here is that when the strings move and create a changing flux, we have a coil wrapped around the magnets that are in the plank of wood, and that coil will experience a current that is proportional to the strings movement. So essentially, the movement of the strings is converted through Faraday-Lenz's law into electrical current or induced EMF in the coil down here, which is the tightly woven coil in the round magnets.
Oh, that's very nice. Okay, so you're already wondering why we had to use 2,000 loops or turns in the pickup, and why not use 5 instead? Well, the reason is because the main principle which this entire pickup is built on is the Faraday-Lenz law, which states that EMF, or electric motive force, which is can be measured in volts, is equal to the negative number of loops we have around that pickup, number of coil loops, times the change in magnetic flux, phi or phi, over change in time. So by having 2,000 loops instead of 1,000, we are actually doubling the voltage, which will make it possible for us to take a small amp such as this one and still be able to clearly hear our electric guitar.
So today we created a single coil pickup with 2,000 turns of the coil. Typically a professionally made electric guitar will have pickups that have around 7,000 coils. That's for the really high quality sounds. Our single coil pickup is, in the music industry, is usually used for hard rock sounds. A lot of metal people use single coil pickups because it's a more distorted sound and there's that kind of hum in the background, which is one of the downsides that people don't like about a lot of single coil pickups, is that they produce this hum. That's why in 1950 Gibson came out with the humbucker, which is designed to eliminate the hum, and it provides a much cleaner sound that's used for jazz and clean sounding rock songs.
This is it. It's 1 in the morning. I want to go to bed, and this is the last time we're plugging it in to see if it works. The whole setup is done.
Just plug it in already?
Plug in. Yeah.
Sounds weird, doesn't it? There's a lot of, oh, that bottom string, it's got a lot of...
Okay, I'm gonna start saying that. There is a house
Turn it down a bit.
in New Orleans. They call the rising sun, and it's been the ruin of many a poor boy. And God, I know I'm one. of children, not to